Okay, so this is the select practice problems video tutorial, right, on helping you through these problems. Um, so a quick word, when I say number one parts A and E, I know number one isn't labeled like A, B, C, D, right? But there are six problems for number one, right? And it's got, and they're like, if this is the paper, right? The problems for number one, right? It says number one, and it's got a problem here, it's got a problem here, it's got a problem here, a problem here, and a problem here, and a problem here before you get down to number two, right? So the problems we're doing are the one that's here and the one that's here. And you'll be able to line it up and figure it out. But those are the ones we're doing right there. That started to look like a really weird like paper bag ghost there. That was kind of bizarre. All right, so it wants us to find exact values. It doesn't say estimate. So when we get to this one, we're going to have to do regular solving. This one, though, however, is a special case, right? So try to remember how that works, right? So you've got x, and then x times the square root of 2. Okay, so I know that if this is our angle, right, and they're giving me this and this, and that's my angle. We're talking about sine. So in this general case right here, we got the sine of 45 degrees is equal to x over x times the square root of 2. And I'll just run through this one more time just for your benefit. So that simplifies to 1 over the square root of 2. Now, generally speaking, I tell you to rationalize these things, right? And I tell you to do it right away. We do not have to do that right now because we're just going to be comparing it to another ratio, right? We're comparing it to this ratio right here. So if that's what we're going to do, then let's just leave it, right? So this is going to be sine of 45 degrees is equal to the opposite over the hypotenuse, right? So the opposite over the hypotenuse is 9 over x, right? And here's my opposite over the hypotenuse. They're 1 over the square root of 2, right? So you can just leave it like this. And you'll see why it's a good idea because we're going to use cross products. So x times 1 is x. And then we got 9 times the square root of 2. So 9 times the square root of 2, right? And then we're going to pull up the calculator, a handy dandy calculator. I won't botch this up like I did last time. 9 times square root of 2 is equal to 12 point, instead of rounding nearest 10, 12.7. Okay, so let's get back on here. So this is equal to about 12.7. Keep in mind this is not an exact answer, right? These are approximations, but they're pretty close approximations. So 12.7, and that kind of makes sense, right? Because you know that this one and this one are equal, and this one is just square root of 2 times bigger, right? Now, what I do know about this one is I know that if I had to figure out an approximate of it, I could. I could use my ratios on this, right? I'm not going to. I'm going to do the exact thing on it. But when we finish, I want to just try it with the ratios to see how close we get. All right. So this wants us to find find the ratio between these two. And the reason they're giving us, or not the reason, but because they're giving us those two, the angle relationship we're going to have to use is tangent. So we're going to say the tangent of 32 degrees, because there's no hypotenuse, right, is equal to the opposite over the adjacent, right? Let's do opposite first, x over 14, right? So this one is one of the easier ones to solve. We don't need to do cross products on this one. So we just multiply both sides by 14. We just multiply this side by 14 and this side by 14. So you're going to get x is equal to 14 times the tangent of 32 degrees. All right, so let's figure out what 14 times the tangent of 32 degrees is and see what we get. So we have 14 times the tangent of 32 degrees. We are still in degrees. We don't have to fix that. It equals, and it's 8.7, right? Really close to 8.75, but we'll just leave it 8.7. All right, so x is equal to 8.7. And that kind of makes sense, right? It should be smaller than this. Now let's think about our 30, 60, 90 triangle, right? So if we approximate this, right? Let's see if this answer makes sense. If we approximate this and they're giving us this, we know that the tangent of 30 degrees is equal to x divided by, and this was x times the square root of 3, right? So that's what they gave us for our thing. So you get 1 over the square root of 3, which we will not simplify again for the same reason we didn't simplify it there. So you get 1 over the square root of 3, and then compare that, should be an equivalent ratio to this, which is going to be x over 14, right? And so when we do a cross products, you get square root of 3 times x is equal to 14. Notice I'm keeping the x underneath that, right? So divide both sides by the square root of 3, and let's figure out what 14 divided by the square root of 3 is. Okay, and see if it's close to the answer we just got. Divided by square root of 3 is equal to about 8.1, right? And we got 8.7 there. So you can see why it's and the reason it's shorter, right, is because if this is 2 degrees more, it's going to go a little higher, right? So you can see that we got close. So I would say 8.7 is a pretty reasonable answer, right? So that is one way you can kind of use some of the relationships you do know if it's close enough to it to check an answer, right? So little weird and a little out there, but kind of fun stuff. All right, this last problem. It says nests. Tabitha's eyes are 5 feet above the ground. All right, so let's just I'm all about pictures. So let's say this is Tabitha, right? Here she is, right? And it says her eyes are 5 feet above the ground, so she's her eyes are 5 feet, right? So 5 feet, 5 feet. You can tell I'm getting tired because I'm like doing weird things here. And it says she looks up to a bird's nest. The angle of elevation is 74.5 degrees. So this angle is pretty steep, right? So we're gonna do this. This is not to scale, and that is not a 74.5 degree angle, right? But let's say that it was. So this is 74.5 degree angle, and she's standing 12 feet from the tree's base. Again, so there's a big tree here, right? Comes down. Here's the ground, and then here's the nest is up there, right? And so 12 feet, right? So this is 12 feet. So again, this is not scale. I'm just drawing a picture so I can figure out how to do this. And it says, what's the height of the bird's nest, right? So if we're going to find the height of the bird's nest, right? She's standing 12 feet from the tree, right? And we were going to find that the height of the bird's nest is going to be this measure right here. Okay, this is what we're looking for. It's going to be this, which is this side of the here, let me color code this. So it's going to be this, which is the side of that. And then we're also going to add to it this 5 feet, right? So the height of our nest is going to be this x plus the 5. So let's figure out what that x is, first of all, and then we'll just add 5 to it, and we'll be cooking with gas. All right, so we are looking at, again, we don't have the hypotenuse to work with, so we're going to use tangent. So we're going to say the tangent of 74.5 degrees is equal to the opposite. Well, the opposite is my x over 12, right? And so we're going to figure this out, and then we're going to add 5 feet to it, right? So it's going to wind up being 12 times the tangent of 74.5 degrees. To get that by itself is equal to x. All I did is I said, okay, I got to multiply this by 12 and multiply this by 12 because this is what happens then, right? Those cancel out and you get x. Okay, so you have 12 times the tangent of 74.5 degrees. All right, so 12 times the tangent of 74.5. Make sure you are in degrees, which we are. It equals, we have 43.3 feet. right? So you could tell this wasn't even close to being scale, right? 43.3 feet high, right? So that's this, right? So we got to add to it the 5. So the total height is 48.3 feet. And that is your answer, right? It was 43.3 feet from basically 5 feet up from where her eyes were level with the tree, right? And then you figure that out. So again, another case of how a poor picture can be misleading. But I'm just using the picture to help me get like the triangle set up and then just trust the process. So hope this is helpful, guys. A lot in this lesson. Just persevere, hang in there. You can get through this. All right.